Good morning, class. I wanted to leave you with one more example of the problems that we're doing today before I set you loose on your own. So if you'd like some help with one more problem, I've got one more problem to do with you. If you go ahead and take a look at number 2 on your sheet, number 2 says, a boat traveled 440 miles downstream and back. The trip downstream took 11 hours. The trip back took 22 hours. What is the speed of the boat in still water, and what is the speed of the current? So this is another one of those problems where we're dealing with distance and rate and time. And we know that the equation for that is distance equals rate times time. And I'm just going to change the order of those things a little bit to make it easier for us to work with. So I'm going to make a chart just like we did in problem number 1. And that chart is going to start with time. And then I'm going to multiply time times rate. And then that equals distance. Alright, so for this chart we're going to be creating two equations. Okay, we're going to separate our time and our rate and our distance. And then we're just going to fill in as much information as we can to complete our chart here. So the first thing that says is that the boat traveled 440 miles. So that's my distance, 440. And it tells me that that took 11 hours. So that's my time, 11 hours. And then it doesn't really say a whole lot about the rate. So I'm just going to go ahead and leave the rate blank for now. On the return trip, this time the boat took 22 hours, so my time is 22. And the distance that it traveled is the same. If you go from Dodge City to Wichita, it's the same distance as going from Wichita to Dodge City. So the distance is the same, 440. And now I just need to plug in my rates here. Okay, when the boat is going downstream, the river is helping push the boat faster and faster. So in that first equation, I'm going to have the rate be the speed of the boat plus the speed of the current. The current is helping push the boat, so I'm going to use a plus. Okay, and on the return trip, again, we're talking about two different speeds, the speed of the boat and the speed of the current, or the speed of the water. But this time the water is pushing against the boat. It's making the boat go slower and slower. So I'm going to have B minus C for the return trip. Alright, so now that I've got my chart filled in, what I need to do is write my equations here. So I'm going to go over here and write my equations. The first equation would be my time 11 times my rate, which is B plus C. And that equals my distance, which is 440. Okay, so when we see an equation like this, I think all of us immediately say, oh, we should distribute this 11. Okay, and that's natural. But a shortcut to save you some work is if we can go ahead and get rid of that 11 right now, it would make life a lot easier. So let's try dividing both sides by 11. There we go, and these 11s cancel each other out, so on the left side I'm just left with B plus C. And then on the right side of the equation, 440 divided by 11, that equals 40. Okay, so I have the first equation written. Let me go ahead and write the second equation. For the second equation, my time is 22. I need to multiply that times my rate. This time my rate is B minus C, and that equals my distance of 440. Again, to save myself some trouble, I'm going to go ahead and get rid of that 22 right now. So I'm going to divide both sides by 22. Those cancel out. So on the left side I'm left with B minus C. And on the right side, 440 divided by 22 is 20. So I've got my system set up here, and it looks like it's going to be perfect for elimination, because it looks like a positive C and a negative C will cancel each other out. I'm going to go ahead and cross those out. and b plus b is 2b, and 40 plus 20 is 60. So after I divide both sides by 2, I find out that my boat is traveling at a speed of 30 miles per hour. Okay, so I'm going to save that. I'm going to keep that in mind. I'm going to go to the next page. I'm running out of room here on this one, so let me go to the next page here. Okay, there we go. We know that our boat is traveling 30 miles per hour. We also know that B plus C equals 40. So if I just replace this 30, if I plug that in for my B, then I have 30 plus C equals 40. Just doing a little substitution. Subtract 30 from both sides, and I get C equals 10. So to summarize, to put all this in perspective, what I know is I know that my boat is traveling at a speed of 30 miles per hour, and I know that the current in the river is traveling at a speed of 10 miles per hour. And that's how you solve these problems that deal with distance, rate, and time. I hope that helps for problem number 2, and good luck on the rest of the problems. Thank you. Bye.